Okay, let's talk about magnetism. What creates magnetism and how is that related to electricity? Well, first off, I really like this picture. You can kind of see it's a bar magnet, and those are, of course, compasses behind it. And you'll notice that the compasses aren't all pointing the same direction, and they're not pointing in random directions. You can kind of see that on this left side here, they're all pointing toward the silver end, and over here, they're kind of pointing away from the red end. Those are magnetic fields, magnetic waves that you can't really see, but they're still there. Well, magnetic force and all magnets that you're used to results from the movement of electrons in an atom. Those electrons might be spinning in place in a permanent magnet, something you have like stuck to your refrigerator there. Now it doesn't look like it, and you really can't look closely and see, hey, I see an electron. You can't see the electrons spinning, but they are there. We'll talk about more in just a second. Or another way that you might see electricity flowing through a wire creates an electromagnet, something you don't see as often around the house, but they still are there. A magnet that can be turned on and off by turning the electricity essentially on and off through this. All right, so you have these materials called ferromagnetic materials, like iron. Iron is something that can stick to a magnet. Well, if you were to look really, really closely, you would see that it's actually divided up into these little small regions called domains. I want you to pause right now and I want you to draw this. I want you to draw this top one and this bottom one. This one is not a magnet. This bottom one is a magnet. Pause and draw this. Now, in each of these domains, in each one of these here, the electrons are all spinning in the same direction. These are all pointing that way, these are all pointing that way, this are all pointing up. When they all align together, it's going to become magnetic. It's essentially going to be a magnet. Think of this as like looking at classrooms in a school. Every single room has got different, like desks pointing in different directions. This one's pointing north, this one's pointing south. Imagine that everyone in the school, everyone suddenly all turned their desks to face due east. That's essentially what happens in a magnet. All the electrons are pointing in the exact same direction. So when they're all pointing in the same direction, it's essentially a magnetic, ferromagnetic material. It's been magnetized. They're all pointing in the same direction. Is kind of cool. You can buy this from VAT 19. This is magnetic putty, which is actually attracted to a magnet here. All of those are lined up, all of those are, spinning in the same direction, and it's actually forming a force that is making this putty, like magnetic silly putty, go towards it. Fun video right here on fun stuff you can do with magnetic putty. So, like this, do you find me attractive? Well, it's a magnet. It's going to attract ferromagnetic things, of course. All right. When electrons move through a wire in a circuit, they create a very weak magnetic field. However, if you loop that wire more and more times, the magnetic field is going to get stronger and stronger. You could actually make a very, very primitive electromagnet with a battery hooked up to a wire which is wrapped around a nail and then to a switch. In this case, it's closed, which means that electricity is flowing through it. This is going to form a very weak electromagnet. The more loops, the stronger the magnet. I want you to draw this into your notes as well. We don't have a lot of notes that you take, but I got a couple drawings that I want, and this is one of them. Battery hooked up to a nail, and then once that is connected or connected through a switch here, it becomes a weak magnet that you can actually turn on and off. But the stronger it is because you've looped it around more and more times. Here's kind of a cool thing. This is a magnetic train, and you can see, like, not moving in the background, but look, it's now using magnets to accelerate. You can see in the background it's moving, and of course that is making the magnets stand on end. It is using the movement of electrons. There's an giant electromagnet down there, and it's powerful enough to actually affect these paper clips there. Fun thing you can do if you're on a magnetic train. All right. Last thing, the electric and magnetic force are actually the same. This little device right here is not a pencil sharpener, though I understand why many people think it is. It's a light bulb hooked up to this crank, and as you crank it, this is going to light up. That's because this is a generator, where I have magnets inside here, and as I spin them around and around, I'm essentially creating electricity. I'm moving those electrons, causing that to light up. Here's an electromagnet, where I use electricity in there to make a very, very powerful magnet. The generator and electromagnet are kind of the same thing. The generator on the left is a magnet that creates electricity. This thing on the right, an electromagnet, is electricity that creates a magnet. They are the same thing. We're going to talk about that more in just a minute, but just remember, a generator makes electricity from the movement of a magnet, and an electromagnet is made by electricity. Same idea, we'll go into that more later.